Okay, so again, we have a literal quiz on Friday. Today we're doing our warm-up. I'm going to go over questions from the homework. We did not get to do our Kahoot yesterday, so we'll do it today. It's on literal equations. Then we have notes on functions. Homework is set C, 5C. Please make sure that if you didn't finish, if when we do, well, no, let's finish that part for homework. We're going to do the literal problems from the worksheet. We're going to finish up the even. If we have time at the end, we can do it here, but we might not have time. Okay. All right, let's look at the warm-up. Let's look at the warm, give you some time to get that done. I'm going to set my timer for about 5 minutes. I'm not going to go through the warm-up today. But you are responsible for it, and then I'm going to go over the homework. Okay, good people, let's go over the homework. I'm not going to go over the warm-up today, but I am going to go over the homework. Okay, so let's go over the homework. Please make sure that you write this down and make corrections so that you'll have it. Go over the homework. Yikes. All right, so we're doing 5B, right? All right, so this is 5B. This is 5B, Tuesday. All right, so let's look at this one. Let me turn this way so it looks like it's... All right, everybody's there? We ready?
Yeah.
Okay. It says the number of deer in Pondunk, whatever, county, that's funny, is growing at a rate of 12% every year or per year. Okay, so it's growing. So you're adding 12% to whatever the population is every single year. It says the hunters are allowed to hunt 25 deer each year. If you're hunting them, that means they're dying. So that's subtracting from the population, okay? If 2010 population of deer was this, okay? So this is what you started off with in this year. What is the predicted population in 2018? That's how many years later? That's 8 years later, okay? That's 8 years later. All right, so we are going to write an equation, kind of like what we did up here before. And I'm going to show you, should I show you that? I'm going to show you how to do it in the calculator as well, because that's probably, yeah, that is a little easier. So row 1 and 2, please pick up your calculator. Pause real quickly. Okay, so let's clear our calculator. 2nd plus 7, 1, 2. 2nd plus 7, 1, 2. Okay, I'm going to show you how to write the next now equation just as we did on Monday. And then we're going to write, then we're going to do it in the calculator to see what it's going to be 6 years. Did we say 6 years later or 8? 8 years later, okay? 2nd plus 7, 1, 2. 2nd plus 7, 1, 2. RAM stands for random access memory. All right, here we go. So with this one, first thing you need to know is what the starting amount is. Anytime you're doing a next now equation, you're looking for your starting amount. So you can say starting at. You have to do this first. It's always the starting amount. What are we starting out with? 1,300 deer. That's the starting amount. Any questions about that? To write our next now equation, we're going to say, we always say this, next equals whatever the current number or the now number is. And now we need to figure out what are they doing to get the next year's population. Well, they are growing at 12% every single year. So we have to find 12% of that number, of the starting number. So we're going to say times, we're going to multiply it times 0.12. That's how you change 12% to a decimal, by moving the decimal over 2 times to the left. So that's 0.12%. This is the number that it increases by. That's what it increases by. So you need to take this increase amount and add it back to whatever that current population is. Any questions about that? So you find the percent, whatever this number is, need to be added back to the current population. Okay? The last thing that it's telling you to do is it's saying that hunters are allowed to hunt 125 of them. So that means 125 of them are going to die. Okay? So at the end, we're going to subtract 125 of them. This is the generic equation that you use. It's called a next now or recursive equation. This is the equation that you can write for these types of problems. Any questions about that? All right, so now we're going to use our calculator, because we would have to do this 8 times to figure out what it would be in 8 more years. So this is how you do this, okay? You're going to type in your current amount, whatever the starting amount is, and you're going to press enter. Pressing enter stores that number into your calculator. The number knows now when we get ready to type in this next now equation, the calculator now knows that that's the first number that you're going to start with. So you type that first number in and you press enter. Any questions about that? Okay, so now we're going to do this part of the equation. Okay, so we're going to put in parentheses, and our now in the calculator is answer in yellow. So we press the second button, and answer will come up just like this. That's now in the calculator. So now you're going to type in times 0.12. You okay? Times 0.12. And then it what? Closes the parentheses. And then you're going to add it back to the now. Add. Answer again is your now. Second. And then you're going to subtract the amount that's hunted. Okay. All right. Yes, baby.
How do you answer?
Answer is the second button and the negative sign. Do you see it? And it's times 0.12. Close the parentheses and add answer again. Minus 125. All right, any questions about how it's typed? If you don't have this typed in, raise your hand so I can help you. Is everybody okay typing it? Hold it up so I can see it, because I am not sure. Where's yours, babe? Calculator? I can't see your calculator. You gotta turn it around. Other way. Do you have it? Mm-hmm. You have it? Store it. You just won't tell me. It's okay. I don't mind waiting. Parentheses? Yep. You put plus. Yeah, smaller number than what you got. All right. So now let's press enter only one time. This is the amount for 2000 what? No. 2000 what? What was the first year was this was what it was in 2010. This is 2011. So press it again. This is 2000 what? 12. Enter again. This is 2000 what? 13. Enter again. This is 2000 what? 14. Enter again. This is 2000 what? 15. Enter again. What's this? 2016. What's this one? 2017. And what's this one? 18. Now you can't have a decimal because you can't have part of a. It's just inhumane to have part of a deer. So it has to be rounded to the nearest whole number. So that's 1,681. Okay. 1,681. Okay. Any questions about that? Did you get it? You sure? Okay. Yes.
What I did is I did the 1,300 times the 12%, and then after I got that, I added I multiplied the 125 times 8.
Why did you multiply? What was the logic behind multiplying 120 something? Yeah, see that? Because you see what I'm saying? Because this 125 is the amount that's hunted. So you're going to have to subtract it because those deers died. Does that make sense? Okay. Yes.
For my answer, I got 1,548. I did too.
Mm-hmm. Well, that's really, 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 really close when you think about it. You see that?
Right, but I thought that it would be right because I got 12%, 1,300, and it was 156, so I multiplied that times 8.
Oh, the only thing, you can't multiply it times 8 because the populations change from year to year.
I know, that's why.
So you have to do it. So when you do it, you can't do it by 8. You have to do it every single time differently. Because as the population change, it's going to be the percent of the new population.
And then I got this.
So you have to take the percent of the new population every single time. So you can't do it by 8 because the population is not going to be that for 8 years. It's going to be different after every single year. Do you not understand what I'm saying?
No, I know, but I thought because with the death part, like, I can't do that. I can't multiply it times 8, and because it was 8 years.
You are not going to be able to do that because every single year is going to be a different number that you're going to have to find the percentage for.
I think I asked my sister for one of these.
Yeah, they have them online on my webpage. On the front cover, you'll see calculators. Scroll down the bottom, and you can download a calculator.
Aren't they like $100?
Yeah, they are. What's your question, baby? Hurry up, sweetheart. Yes. Yeah, you can go. You can go today. But did you ask me before him?
Yeah.
Okay, then just wait and go after him. I forgot. I'm sorry. I wasn't discriminating against you today.
Okay.
Yesterday I did. Because you was talking. All right. But today you was good. So just come when he comes back, babe. All right. Okay. Any questions about that? Are y'all okay? Does that make sense, Peyton? Okay. All right. Good deal, baby. Okay. So look, the rest of these, I didn't see where you guys had any problems on some of them. This one right here to the nearest 10th, I didn't see anybody had any issues with that. Is there any issue? You want me to do that one? Number 4. Okay. What about 3? I was going in order. Sorry. Just want to make sure. No questions about number 2 or 3. Okay. Those are pretty simple. Let's do number 4. Number 4 says the depth of the pool and the number of hours it's been draining. So look, these are two variables. You have to decide which one would you graph along the x-axis, which would be your independent variable, and which one would you graph along the y-axis, which would be the dependent. That's the variable that depends on the other. Which one is dependent? Is the depth of the pool dependent upon the hours it's been draining, or does the hours that it's been draining depend on the depth of the pool? Which one would you graph along the x-axis, the independent, and which one would you graph along the y-axis? Which one would you graph along the x? The hours. You would graph the hours. The hours is independent. Hours that it is not cannot go back. You can't go back in time with hours. It's independent. It's unaffected by anything else. All right. But the depth of the pool, the height of the pool, how deep it is dependent on the hours that it's draining. So the depth is the dependent. The depth of the water is the dependent. Does that make sense to you? Is that okay? All right. Go ahead, baby. What's up?
Question about number 6. Like, what are you supposed to write?
For number, which one?
6.
All right, let's get there. Let's write this one first. Dependent is the depth. Deep. Bless your teacher's heart. It's always messed up. Y'all don't know how to act. Go ahead. Y'all don't know how to act. Those boys are terrible. The 700? Yeah, that's fine. All right. Okay. This is number 4. Number 6, you said? You said 6, right? 6, this is the formula. Okay. So we're going to write that formula down. T is equal to C over 4 plus 40. This is the one we did on Monday, right?
Yeah.
Okay, so this is what it's saying. You're going to take this formula, relates to T temperature. So T represents the temperature in degrees Fahrenheit to the number of chirps, C. Okay. What is the temperature? So we're looking for T. Okay. It says, what is the temperature if the chirps is what? 168. So C is 168. So that's what we're going to substitute. We're going to substitute 168 for C. 168 divided by 4 plus 40. Does this make sense to you?
So if you just write the solution.
So now you solve for T.
Oh, okay.
Oh, I got it mixed up.
I was confused. Oh
Do you understand that now, baby? Okay. This is just like the one we did on Monday. So now let's divide. We got 168 divided by 4, right? Which is 42. And then we add 40 to it. And what does that give us?
82.
82. So the temperature is 82 degrees what?
Fahrenheit.
Okay. All right. Any questions about that? Yes, baby. Go ahead.
I'm pretty sure for me, I subtracted this temperature instead. And
Okay.
then put the 168, and then I got 512.
So do you understand that you have to look to see if they're talking about if they gave you the temperature or if they gave you the chirps? And whichever one they gave you, that's what you substitute. Okay? Good job, babe. All right. Any other questions about that? Okay. Any other questions about the homework? What about number 7? Do you understand that you're using this equation for number 7?
Yeah.
Okay. All right. Any questions about the others?
Also for number 1, after you do the next noun equation, what do you do with the 8? Then what?
We did 8 times in the calculator. I'll do that one again. You type this equation in to the calculator. So you have 130. The 8 tells you how many years do you need to do this for. So if you're doing this on paper, you would have to literally substitute this in 8 times. That's why I said, let me do it in the calculator. Because that's a lot of times to do this equation. Here, you're going to type in, what is that, 1,300, and you press enter. And then you type this equation in. So the equation, if you remember, we did parentheses. We did the second answer button for now. Do you remember that? Yes, you remember? Okay. Times, oops, it's not times, Miss Reyes. Times 0.12. Do you remember that? Then we add it back to the now, and then we subtract the 125 deer that are deceased. So we do, this is the year 2000 what? No, the starting was 2000. This is 11. So you got to do it 8 times. This is 2011. This is 2000 what? 12. Press enter again. 2013. Then 2014. Then 2015. 2016. 2017. And 2018. You're welcome. Okay. All right. Okay. Are we okay? All right. So tonight's homework, let's look at this real quickly so you'll see what you're doing again. This one is just like Monday. This one's just like Monday. So you have your starting year again. It says population of Wilson in 1990 was about 4.7 million. This is your starting amount. Okay. The following information in the Census Bureau, same thing we did Monday. Annual estimates to the change based on the current trends. Births, that's adding. We're adding this percent. Deaths, we're subtracting this percent. And then again, immigrants, people that migrate to that country, we're going to add 0.4 million people. So to write that in next now equation, I'm going to put that down here for number 1. What did we say we were starting at? What are we starting with? What's the starting population again? 4.7 million. Good job, babe. Okay, that's 4.7 million. We automatically write next equals now. Okay. We're going to combine, just like we did Monday. We don't want to do the percents twice. So let's combine these 2 percents together. Births is positive 2.8%. Deaths is minus 0.8. Let's combine them together so that we don't have to do them separately. We can just go ahead and do those together. So when we combine those 2 amounts together, what percent do we get? 2%. So we're going to add 2%. How do you write 2% as a decimal though? Okay, very good. Move it over to the left. So it's I forgot what you said. 0.2. Okay. Yeah, this is what I think you were saying, 2.0. 2.0 is 200%. You didn't move the decimal over enough. Okay. But this is 2%. Okay. Any questions about that? Okay. So now we're going to multiply the percent. This includes both the deaths and the births. This includes them both. So I don't have to do it twice. Now, what's the last thing that well, not the last thing. Now I got to take this increased amount and do what with it? What do I have to take with this increased amount? Go back and look at the previous problem that we did. Look at the one that we just did. What do I have to do? You have to add it back to whatever the current is. Now, what are we going to do with this? What's the last thing that they said that was going to happen with the population? Very good, the immigrants. And so what is that? How many people is that going to be every year?
0.4 million.
0.4 million. Okay. This is the equation. Any questions about number 1? Okay. All right, good people. Everything else should be fairly simple for you to do tonight, okay? All right, let's go ahead and take out our laptop, please. And you need a scrap piece of paper. What was the last part of the equation? You got it? You need a pencil? Yes, baby, I'm sorry. Uh-huh. Is he back yet? Right here. When he comes back. As soon as he comes back, you can go. Yes. Yes. All right, so look. This is what I need from